Our sun. A blazing ball of plasma. A churning cauldron of nuclear fusion. It gives us light, warmth, and life. But the sun also possesses a hidden fury. Solar storms. Imagine a colossal eruption on the sun's surface, a sudden release of energy equivalent to billions of atomic bombs. That, my friends, is a solar storm. These storms hurl enormous clouds of charged particles, called Coronal Mass Ejections, or CMEs, into space at mind-boggling speeds. Traveling at millions of kilometers per hour, these CMEs can reach Earth in a matter of hours or days. While our planet's magnetic field acts as a shield, deflecting most of the solar material, some particles manage to penetrate this defense. When these charged particles interact with Earth's magnetosphere, they trigger a cascade of events known as a geomagnetic storm. These storms can disrupt our technology, affecting everything from satellite communications to power grids. In a world increasingly reliant on electricity and interconnected systems, understanding and mitigating the impacts of solar storms is paramount. Let's delve deeper into the real-world consequences of these celestial tantrums and explore how science acts as our shield against the sun's fury. Imagine this. You're flying across the Atlantic, relying on your GPS for navigation. Suddenly, your signal goes haywire, the map on your screen a jumbled mess. This, my friends, is just one way a solar storm can disrupt our lives. The charged particles from the sun interfere with radio signals, impacting GPS accuracy and even causing radio blackouts. But the havoc doesn't stop there. Remember that beautiful aurora borealis, the northern lights? While captivating, these dazzling displays are a visible reminder of the sun's power. During intense geomagnetic storms, the auroras can intensify and expand towards the equator, disrupting power grids and causing widespread blackouts. One striking example occurred in 1989, when a powerful solar storm crippled Quebec's power grid, plunging millions into darkness for hours. Satellites, too, are vulnerable. In 2003, a series of intense solar flares damaged sensors on several satellites, disrupting communication networks and weather forecasting systems. The threat is real, the stakes high. So how do we protect ourselves from these celestial storms? Let's explore the science and technology that act as our early warning system and shield. Imagine a fleet of spacecraft, constantly monitoring the sun's every move, like vigilant sentinels guarding our planet. That's precisely what we have. Spacecraft like NASA's Solar Dynamics Observatory, or SDO, and the joint ESA-NASA Solar and Heliospheric Observatory, or SOHO, provide us with a constant stream of data about the sun's activity. These space-based observatories track sunspots, solar flares, and CMEs, giving us valuable time, sometimes hours or even days, to prepare for potential impacts. Sophisticated computer models use this data to predict the trajectory and intensity of CMEs, allowing us to assess the potential risk to Earth. Just like meteorologists issue weather warnings, space weather forecasters issue alerts about impending geomagnetic storms. These alerts enable satellite operators to take protective measures, power grid managers to adjust loads, and airlines to reroute flights, minimizing disruptions and damage. Section 4. Shields up. Protecting our planet from solar wrath. So, we can predict these solar storms. But how do we protect ourselves? One crucial aspect is hardening our infrastructure. Power grids, for instance, can be modified to better withstand geomagnetic disturbances. This includes adding surge protectors, enhancing grounding systems, and developing strategies for rapid recovery after a storm. Satellite designers employ radiation-hardened electronics and shielding to protect against the damaging effects of solar radiation. Critical systems can be placed in safe mode during intense solar events, minimizing damage. Furthermore, backup systems and redundancy measures ensure that essential services remain operational even during disruptions. But our most important defense, perhaps, is knowledge. By understanding the science of space weather, we can better anticipate and mitigate the risks posed by solar storms. International cooperation and data sharing among space agencies worldwide are vital for accurate forecasting and timely response. Section 5. Space Weather Warriors. The ongoing battle for our electric grid. As technology advances and our reliance on electricity grows, so does our vulnerability to space weather. The battle against solar storms is a continuous one, requiring ongoing research, innovation, and collaboration. Scientists are constantly working to improve forecasting models, develop new shielding technologies, and enhance our understanding of the complex interactions between the sun and Earth. Just like we prepare for hurricanes and earthquakes, we must prepare for the inevitable tantrums of our nearest star. By harnessing the power of science and technology, we can bolster our defenses, protect our infrastructure, and ensure the continued functioning of our technologically dependent world. The future depends on it. The cosmos awaits, and it's up to us to explore it safely.